All right, continuing on our journey in quadratic equations. So yesterday we learned what a quadratic equation was. Remember, that's any equation that has an x squared but nothing higher, right? And then we got our first method to solve those quadratic equations, and that was using a square root. So if I had something squared, x squared, a parentheses squared, and nothing else, just plain numbers other than that, then I could use a square root to solve. So today we're going to talk about another method in order to solve these quadratic equations when we have an x squared and an x involved. So what happens if I can't use a square root? Here's another method to solve. So we're going to talk about this method, and it involves this thing called zeros, and we're going to learn how to use that in order to solve these quadratic equations. So as a warm-up, really getting our brains into this zero mode here. See if you can fill in the blanks. Pause your videos and go for it. All right, I hope these were pretty easy, right? 3 times what equals 0? Well, 3 times 0 equals 0, right? Number 2, blank times x equals 0. What times x would make the whole thing equal 0? Will have to be 0 times x, right? So if I notice in the first one, 3 times 0, if 0 is the second number when I'm multiplying, the whole thing equals 0. The second one, 0 times x equals, so 0, if 0 is the first factor, then the whole thing equals 0, right? So if 0 is a factor here, when we're multiplying together, then the whole answer equals 0. So in number 3, even if I'm multiplying this whole parentheses, x minus 5 times 0, the whole thing will equal 0, right? So if I take 0 and multiply it by anything, the whole thing will equal 0. So then on number 4, sure, I could have both of these blanks equal 0, or I could have 5 times 0 equals 0, or I could have 0 times x squared minus 5x plus 3 equals 0, right? However you want to do that, but as long as one of those blanks is 0, the whole thing equals 0. And that's going to be a huge key in our lesson for today. So if we put this in context of a quadratic equation, right? Let's take a look at this. Now here, I have 2 sets of parentheses. I have x minus 2 times x minus 9, right? Now you might be thinking back to the last unit and saying, oh, I know what to do with those parentheses. Yeah, I could FOIL or distribute. I know what to do with that, but I'm going to say pump the brakes here, right? Now you can think about that. If I would FOIL or distribute there, I would end up with an x squared and then negative 11x and then positive 18, right? So this would be a quadratic equation, but I don't want you to multiply. I want you to think about what we just talked about in our warm-up. Look at number 3. It says that this, whatever this parentheses is, x minus 5, if I multiply it by 0, the whole thing will equal 0. Notice, that's what I'm trying to do in this one too, right? I'm trying to make this whole equation equal 0. So if I look at number 3 in my warm-up, well, that said that if I make this parentheses equal 0, that would be multiplying by 0, right? And the whole thing would equal 0. Well, what would make that parentheses equal 0? I could just add 9 to both sides and I would get x equals 9. So if x equaled 9, that whole equation would equal 0, right? Because I'd have x minus 2 times 0, which would equal 0. But if I think to my warm-up again, like in number 2, what if 0 was the first term? So what if this first factor equaled 0? X minus 2 equaled 0. Okay, well that means if I added 2 to both sides, that means x could equal 2. And if x equaled 2, this whole thing would equal 0, right? Because this first parenthesis would be 0, so it would be 0 times x minus 9, which would equal 0. So here are our 2 solutions to my quadratic equation when it's set equal to 0. I could take either one of the factors and make it equal 0. If I have these factors, 2 things that are multiplied together, if I could make either one of those factors equal to 0, the whole thing will equal to 0. So those are my solutions, right? This is the basis of our new method of solving quadratic equations. So what we just did there, we found the zeros of that quadratic equation. So anything that would make either one of the factors equal to 0 are called the zeros. So this x equals 2 is one of the zeros, and x equals 9 is the other zero. So they're the solutions and the zeros. Those are the same thing, right? In fact, these are also called the roots of the quadratic equation. And that probably makes sense after doing what we did yesterday, right? We solved with a square root, so these are roots. It'll also make sense when you get into graphing in the next part of Unit 6, because these are the places where this equation is rooted to the x-axis. So it's pretty cool because a solution to a quadratic equation has 3 different names. It could be called a solution, it could be called a root, or it could be called a zero. And that's because of all the different methods there are to solve a quadratic equation. All right, so remember that 0 is any value that makes one of the factors equal to 0. Now notice when we solved that, our equation had to equal 0, and we had our equation factored, right? So we had to have these factors, and the whole equation had to equal 0. So those are kind of our steps, which we'll kind of ease our way into in this lesson. So we have to first make sure that the equation equals 0. Sometimes we might have to move some terms. If the equation isn't factored yet, then we have to factor it first, and then set each each factor equal to 0 to be able to solve each one of those. All right, so notice that this method is also called solving by factoring because we have to make sure that we have factors in order to find those zeros. All right, so let's really look at what this looks like. Now, I know that we haven't looked at any equations yet that have said that they equal y. This is kind of an introduction into the next part of Unit 6 where you start graphing, right? We know that graphing lines y equals mx plus b, we have y and an x. So this is kind of what it would look like, a little preview. Excuse me. But notice the directions say to find the zeros. And remember in our method for making sure that we are finding zeros, it says to make sure that the equation equals 0. So what we're going to do, sorry about the bell, is we are going to take this y and we're going to replace the y with a 0. So it'll say 0 equals x minus 3 times x plus 5. Now it should look exactly like that problem we just finished, right? It's already factored for us. Notice we have 2 things that are multiplied together and it's supposed to equal 0. So I know that these 2 equations, these 2 parentheses would be pretty easy to use mental math, but I want you to make sure that you process through and write those equations out as x minus 3 equals 0. We have to set each one of those factors equal to 0 and x plus 5 equals 0. I know they're very easy equations to solve, but make sure that you're writing that step down. Sometimes those equations won't be as easy, and if you don't write those down, it's very easy to get your negatives mixed up. Because remember now here in my first one, x minus 3 equals 0, I have to add 3 to both sides. So my solution is actually x equals 3. That's my first 0. And if you don't write that equation out that says x minus 3 equals 0, it's very easy to say the answer is negative 3 because the factor is x minus 3. So make sure you write those equations so you get your negatives correct, okay? In the second one, I have to set the second factor equal to 0, and then I would have to subtract 5 from both sides to move that, so I would get x equals negative 5 as my second solution. So the process is make sure your equation equals 0, set each one of the factors equal to 0, and then solve each one. Those should be very easy equations to solve, but make sure you write them out. So in number 2, I notice again it says y equals, but I want to find the zeros, so I'm going to replace that y with a 0. So it'll say 0 equals x times x plus 8. And again, I have factors already. I don't have to factor this one because they're already factors. I have 2 things multiplied together that will equal 0. So if either one equals 0, the whole thing does. So I'm going to take this first factor of x equals 0, right? Hey, that is an answer already. No solving needed, but I have an answer of x equals 0. And then I take my second factor, which is x plus 8, and set that one equal to 0. I subtract 8 from both sides, so my second solution is x equals -8. So I have two solutions, 2 zeros for each one of these equations because I have my quadratic, right? Think back to yesterday. I had that plus or minus, right? I had those two answers. You're still getting two answers when we use this method as well. And that's why it's really important to make sure you're setting each of those factors equal to 0 so that you don't miss one like that plain x sneaking out front in number 2. Okay? All right. Now, those were already kind of set up for us. Let's get back to looking at a quadratic equation like we would normally see it, like you saw them yesterday in your lesson, right? So here's our quadratic equation. X squared plus 10x equals -21. This one's not factored for us, right? So we have to do the whole process. But remember, step 1 of the process is to make sure that the equation equals 0. So in this one, in number 3, I first have to get this equation equal to 0. There's no y to replace. Instead, what I need to do is move this 21. So I'm going to add 21 over to this side. So I get 10x squared plus 10x plus 21 equals 0. So make sure that it equals 0 before you start the process. Now, I need to factor this, right? I don't have two things multiplied together yet. I have my, quadratic equation. I have my trinomial over there. Oh, do you guys remember how to factor trinomials? Boy, do you remember all the ways to factor? Let's see, the most common way to factor was GCF. You can use that for any number of terms. Do I have a GCF, x squared, 10x, 21? I don't. Okay, but that was a good review, right? I could use dots. Remember, this was for 2 terms only. It's not 2 terms, it's 3 terms. Okay, then I could use factor box or guess and check or whatever you guys use. You don't have to use a factor box, but whatever method, that's the trinomial, right? That's the 3 terms. Okay. We have that bin squared shortcut as well, if you see it. Or we have grouping if it's 4 terms. Whoa, sorry. There we go. All right, so hopefully you remember all your different ways of factoring. That was just a couple of days ago at the end of the last unit, so should be fresh. So this one is going to be our factor box. Now, you don't have to use a factor box if you don't want to. Remember, you could always just use the guess and check. But we should end up with 2 binomials here multiplied together that equals 0, just like in our last problem. So if you do use a factor box, this is what it would look like. Remember, x squared goes up here, 21 goes up here, 10x goes down in the nook. What things multiply together to give x squared, x times x? What multiplies together to give 21, 7, and 3? And they have to add up to 10x. 7x plus 3x does equal 10x. So then I have my diagonals as my parentheses. So I have x plus 3, and I have x plus 7. Again, you could do that without the factor box. In fact, I'll probably, maybe not show the factor box every time, but that's the method we're using here, right? Now I have my 2 factors, x plus 3 times x plus 7 equals 0. Make sure you bring that equals 0 down because we are solving. Don't lose sight of your equal sign. And now it's just back to these ones that we did before. It looks exactly like number 1, right? So I take each one of those factors and I set it equal to 0 to solve. So I have x plus 3 equals 0. I'd subtract 3 from both sides. X equals -3 is one of my solutions. And then I have x plus 7 equals 0, subtract 7 from both sides, so I have x equals -7 as my second solution. All right, so that process, that's the whole thing, start to finish, right? If I want to solve this equation by factoring, that's the same thing as called finding the zeros, right? It just means that you have to do a little more work. First, you have to set the equation equal to 0, then you actually have to factor it if it's not factored for you. You set each factor equal to 0 and you solve each one. So let's take a look at number 4. A little bit more to move here to get it equal to 0, right? So first I'm going to subtract 6x. Notice I have a like term over here. Then I'm going to subtract 2 from both sides. So I'll have 3x squared minus 5x minus 2 equals 0. And now I have it equal to 0, so now I can factor it. Remember, don't factor until you get it equal to 0. All right, so now I'm on to my factor box, right? I get my two binomials ready. Remember to bring that equals 0 with it. I'm going to throw my factor box over here. Again, if you don't use a factor box, you can use whatever method makes sense to you. I have 3x squared up top, I have negative 2 up top, and I have negative 5x down in the nook. So let's see, that would be 3x and x. That would be negative 2 and 1, which would give me negative 6x plus 1x, which is negative 5x. Now remember, diagonals are your parentheses here, right? So one set is 3x plus 1. The other set is x minus 2. So whatever method you use, you should end up with our factors of 3x plus 1 times x minus 2. And now I'm going to set each one of these equal to 0. So I have 3x plus 1 equals 0. And this is why I want to make sure that you are writing these mini equations out, right? This actually is going to take a little more work. I'm going to subtract 1 from both sides. I get 3x equals negative 1. Watch those negatives. Now I need to divide both sides by 3. It wasn't just a one-step problem, right? So x equals negative 1/3 is one of my solutions. And notice that's why we write those little mini equations out. Now I set my other factor equal to 0. X minus 2 equals 0, so I add 2 to both sides, and I get x equals positive 2 as my second solution. All right. A couple more to practice here, right? Don't forget you have all of your methods of factoring, not just your factor box. Many of these will be a factor box because when you have that x squared and an x and a plain number, which happens a lot in quadratic equations, then you're going to have to use that factor box method, but not always, right? And don't forget about those others, especially your GCF, right? Dots will come into play a little bit, but for sure look for those GCFs. It'll make your life easier. For example, number 5, this one does have a GCF. Factor that GCF first. It'll make your life so much easier. But notice it already equals 0, so we're ready to rock and roll here with our GCF. So I'm going to pull that 4 out because that's my GCF, and I get x squared minus 6x plus 9 equals 0. Now, before I do anything else, you could leave that factor of 4 out front. But in this case, think back to yesterday, right? When I had that number outside of my parentheses, I can just get rid of it by dividing both sides by 4. That's going to just make our lives easier. Now I'm down to this much easier trinomial, x squared minus 6x plus 9 equals 0, because 0 divided by 4 is 0. So factor that GCF out, but then divide both sides by that GCF so that your life gets easier. Just be careful that if that GCF has an x in it, you can never divide by x. You would lose an answer that way, okay? So just only if it's a plain number that you can divide. So now I'm going to get to factoring that trinomial. Use the factor box if you need to. Hopefully this one should be pretty obvious though. This is an x minus 3 times x minus 3. Negative 3 times negative 3 multiplies to give me positive 9 and adds to give me negative 6. Could also have used a bin squared on this one, right? Now if I take each factor and I set it equal to 0, I'll get x equals positive 3 over here. I'll get the same thing from this one. When I have a bin squared situation, I'm only going to have one answer, and that's okay, right? Technically, I have 2 answers here, but they're the same number, so I only list it once. I wouldn't say 3, 3, right? It's just the solution is 3. But the reason that it is only one solution in this case is because that was a bin squared. Both of those factors are exactly the same. So technically there's 2 solutions, but they're the same number. All right, so there is a very rare situation where that could happen. Let's take a look at number 6 now. Here I have x squared equals 6x. So my equation does not equal 0 yet, so I definitely want to subtract 6x, move it over so it equals 0 first. X squared minus 6x equals 0. Now that it equals 0, now I can factor. Now I'm sure you're starting to panic. Oh my goodness, Mrs. Crivo, there's only 2 terms there. I can't use a factor box. What do? I can't use a factor box with 2 terms. Don't panic. Remember your other methods, right? What do I look for first? I look for a GCF. Take that x out. That's the GCF here. I'm left with x minus 6 in my parentheses, and at equals 0, don't forget to bring that equals 0 down. Now, do not divide by x, ever. Do not ever divide by x, okay? We could divide that GCF on the last problem because it was a number. If you have an x, you cannot divide by x. That's a factor. That's one of our answers. You gotta keep it. Do you remember back to this one way up here, number 2? You remember this guy right here? Hey, they factored it by GCF. We gotta make sure that we keep that solution in the mix. That's one of our answers. So I'm gonna take that factor and I'm gonna set it equal to 0. X equals 0 is one of my solutions here. I'm going to take my second factor, x minus 6, and set it equal to 0. Add 6 to both sides, and x equals positive 6 is my second solution. Remember, do not ever divide by x. If x is your GCF, that's a factor. You got to set it equal to 0.